Okay, hello everyone. I'm Adarsh. I'm very new to this uh, creating lessons part. I generally prefer doing one-on-one sessions on this kind of stuff, but I saw a bunch of content online where the presenter was giving kind of repeated mugged up answers. These were very traditional answers, no thoughts given. This is the best answer that GPT gave them. They were just blurting it out. And I thought, except one or two maybe creators, I did not find anybody. Like most of the creators I found on YouTube were actually giving very subpar information on how to approach a DSA problem, how to solve it in an interview, what kind of things you need to think when you're solving it in an interview, and a kind of real idea of how to clear these interviews actually. Why am I good to do this? Because I have cracked multiple interviews and I'm currently working as an SDE2 at Microsoft, so I should have definitely cracked it, right? So I've been through the process very recently. I So yeah, this was a basic introduction, and this is the only video that will contain this kind of introduction. Or the other videos will start with me explaining what the problem would be, and then diving into the solution, and not in a way the most traditional people are teaching it, but more of in a way that how you would want to approach a problem in an actual interview, and what things you might do or not do in an interview. And I will also tell you how to build that intuition if you come across a problem that you have not seen, how to structure your code to put you above at least 90% of the people who are going to interview along with you. So yeah, let's go through some of the problems right now. So instead of having a problem selected already with me, I would actually go on Leetcode. I'll select one of the problems, and then I'll pick that problem up. I'll tell you how I would think about it if I have not seen it. So I'll keep it here and I'll just do a quick scroll. Whichever it lands on, we'll do that. Okay, very interesting. Oops. Okay, how do I copy this? I need to copy the problem. Everything needs to be copied. And we go to our tutorial section. Okay. Let's put it here and then we'll read the problem. How do I do this? I want the color to be white. Right. Okay, cool. So given an array of integers nums, there is a sliding window of size k, which is moving from very left of the array to the very right. Okay. Now you can only see the k numbers in the window. Okay, interesting. Each time the sliding window moves right by one position. Understood. Return the max sliding window. The max sliding window. Let's figure out what that means. Okay, we are given these numbers 1, 3, minus 1, minus 3, 5, 3, 6, 7, for which k is equals to 3. So our window will always be of size 3. Okay, the output is 3, 5, 5, 6, 7. The maximum is what we want of everything. Okay, so the sliding window would begin with here, is what I'm assuming. It will start with 1, 3, minus 1. The max would be 3. then we move by 1 and I remove this and I'll get minus 3 here, right? I'll get minus 3, right? Yes. Okay, minus 3 here, and max is still 3. The next time I move one more, I get in 5. I remove 3, so now I need to somehow make sure that I know how to how to, I mean, what element is the maximum. So here, that is why we got the 5. I move one more, I get 3. I discard this. I am still 5 as max. Till here I get to 3. I get to 6. It so happens that I am still at 5 as the max, and I get 7. So I remove the max. I get the number that I got, which is greater than max, and I can return that this is the maximum now, and I have to somehow remember that this has been removed also. So the interesting part here would be, what if this was not the maximum element? What if I had another element in this which would have become the max if I removed it, right? So I would have had 3 6 sorry, I would have had 3 how do I would have had 3, I would have had 6, and then I would have had 7. If, let's say, this was not 7 but let's say 5. Okay, wait, the moment 6 came, the maximum would have been 6. Okay, right, that's what I missed 6 there. Okay, so the maximum would have been 6, and then I would have come to 7. Okay, now what if this was not 6 but 2, and this was also maybe 1 or 2, let's say 1, then I would have had to somehow know that if 5 is not what I am looking for, 3 is the next max, right? So this can I solve it using okay, so one thing, the bare minimum that I will have to do is I keep this n-sized window running, and so basically I'll have to just follow with I and j on a much bigger array to maintain the sliding window effect, and then I'll have to just check in this which one is max, right? But my problem with this approach is that we have already seen these elements. Right? The only time a max would change is if some new number comes in which will replace this max, right? So if we do that and somehow okay, so something is greater than that and we keep it as max, we need to keep that in track. Like I need some way to keep in track that this is the second element which is greater, in case somehow we are moving out the max element out, right? Okay, so let me clear this thought up a little more. This is something that I would generally do in a pen and paper first. I'd explain this part of the thinking where I want to do this, and this is how I would do it. This is something that I would do generally parallelly to think about this part. I actually am seeing this problem for all the first time only, I guess. So okay, we put m in this. Let's say something less than m comes in. Okay, I'm trying to think of an edge case. Let's say something greater than, can something greater than n come? And okay, so in that case we already have the maximum, we don't have to think about it. But what if we remove the m? That is no longer the maximum, right? So one more thing I can think about is keep a max right here which will contain the value of max, right, max I, which will contain the value of max. If this I goes out of range of the sliding window, what I want to do is I want to run one more pass and get the max I again, right? This might reduce the time complexity a bit, like actual running time by a bit. The complexity will still be order of n square only, where n is the size of the array. But anyway, so but if we still do this, I'm still not really optimizing, and it's still of order of square, which I'm not liking. I need to somehow keep a track of the maximum in the window, and if this maximum is pushed out, I need to also keep a track of the second. So I can contain this whole part in like a queue kind of a structure maybe, right? So if the sliding window is moving, I keep this max I in a queue, but how this is sorted, right? So max I is the maximum element. Anything lower than that I need to keep in a sorted, it will be inserted in a sorted manner only, right? So what I'm trying to say is, let's say if we take this example itself, what will happen in my array is I have 1, 3 and minus 1 initially in my array, where it would be something like 3, 1 and minus 1, which will keep track of this second maximum thing as well, right? Now what I want to do is I move it to the next part. I push out 1, so this does not exist anymore in this array, so I'll need to push this out, and I need to put minus 3 in it, and this will go in the end because this is the minimum. I can use something like a max heap for it, and whenever you remove an element, somehow I'll have to mark it as deleted from the max heap as well. That I see is getting a bit more complicated than I wanted it to be. So okay, but I mean, I guess I will still cover this idea because it's still in the thinking stage, right? Okay, okay. So what I have done till now is I have come out with the one real problem of this problem, that is to maintain the order of the elements from greatest to the smallest in this sliding window, in a way that if I remove a number, I should be able to still remove that number directly, right? I'm trying to think of a way where this presence of this will be a problem. Okay, this will be a problem because there are still cases which will cause this. Let's think. Right, how will I solve it? Insert sort will mean that I'll have to, in the worst case, sort it in n square time, which is even worse. This element at any time will contain only k, so it's still order of k square, which is still worse. Can I keep it sorted? I can't sort it because I need the sequence because of the sub-array part of it, not subsequence of it. What more can I do? Right. Okay, let's do this instead. If I see a number, okay, I'll create this deck kind of structure. So what I want to do is I want to keep all the greater elements on this side and all the smaller elements this side, right? Why I chose a deck? Because it is order 1 to insert on both ends and remove from both ends. So that was my thinking. Right, let's okay, let's let me try this out once. I get 1, it's empty, so I can put it anywhere. Let's say I put it here. I get 3. So because I got 3, something greater than already in the front of this deck, I'll put it on the front of it. Then I get a -1 and I'll insert it from the back. Right, so this is the current situation, and the first element of this deck will be my greatest element. Now I come to -3. Right, 1 is removed, but let's keep it for a bit. Let's see, do I really need to remove it? I actually might need to remove it. Okay, so 1 is removed. I pop from the deck until I remove this element, and then I push it back. I push everything back. If the whole array is sorted, that would mean I will have to just continuously, okay, removing that won't be an issue. So this is completely jumbled. I need to push and pop every time. Not a good idea. How do I handle that? What if I only focus on the minimum and the maximum element? That would cause a problem still, because then 1 will not become a second largest. Oh, okay. I don't think that would be a problem ever. Right, interesting. Okay. So what I'm thinking of is, let's say, let's do this as dry run first, and then I'll try another dry run. So what we do is we start with 1, 3 and -1, 1, 3 and -1. This is my deck. What I want to do is, if I see a number greater than this, I put it here. If I see a number less than this, I put it at the end. Right, this is the whole game. Okay, I see -1, I put there. I see -3, I put it here in the end. I put -3. Now 1 is at the middle, but I am going to ignore it for a bit. I am here till now. I move to 5, -1. I will remove this, and I will insert this in the front, because I have expelled this out, so I need to put this out. Now I am at 5, so 5 will be the greater one. I put 3. I am pushing out what, -3. Did I push out -3? Oh no, I pushed out -1. Okay, so for my reference, I'll be deleted. I put 6. I see 6 is here. Am I moving out of the window? I am not moving out of the window, so I'll put 6 here. And Put 6 here, 5 here, and so this will contain 6, 5 and 3. So 6 becomes the greatest element. I move to the end. 6 becomes the greatest element, 5 was deleted. And okay. Now let me think of an edge case where okay. Let's take a numbering where so I want to take a number where somehow my second largest also gets evicted along with my greatest. So my edge case thinking is, what if something happened and my second largest was no longer the second largest? Is that a possibility, is what I'm trying to think. So in the previous case, what would have happened then is I would have gotten 3, I would have gotten a 1, I was starting with -1. What if I added a 2? Could I have added 2 here? I could not have added 2 here. Which means if I put that at the end, it would have caused a problem though. Let's check the constraints of this problem once. It's 10 to the power 5. So I have to do it in order of n somehow. Order of n time. How do I maintain an order of n time without this? Right, so let's say 1 was moved out. We had 1, 3, -1, 2. Right, and then maybe another 2. Right, in this case what would have happened is 2 would have become the next 2 would have become the point, the second greatest number, but as of now we have it as 1. What to do in that case? Can I iterate over this and just replace the number? But then how is this better? Instead I can do this, because this will be in some kind of sorted manner. I don't know, man. Max it will go to I and k. Max this will go to k. If it's minimum, I need to some homogeneous logic for this. Okay, so how can we maintain the sequence here? What I will do instead is, let's say we have this deck, I have my numbers, I let's say get to 2. 1 and -1 can never be greater, right? Because 3 was maximum, now I got 2. So the second, even if 3 is removed, the second maximum would be 2, right? It cannot be 1 or -1. So what I do is I just remove everything that is smaller than 2 maybe. So basically I'll keep a track of some a amount of greatest numbers. Anything that is less than 2, that is less than 2 before 2, would anyways will never be the maximum element of that subarray, right? Like that also does make sense, kind of. So I have to just remove all of these. Okay, so now what I do is, basically I want to contain this kind of structure using my deck. Okay, now I get to a index where I have like taken this out. So I'll just remove it from the top, and then I see 2, another 2, I'll put it in the queue, it's in the deck still, not the queue, sorry. It will still be in the deck because there is a possibility that even if I remove this one, this element, I still can become like 2 can still become the greatest if we take like 2 1 1, for example, right? Okay, that I think takes me to, okay, so that will be order of n solution, because I'm seeing every index um, only twice, I guess, because one time I'm putting it in the deck and the other time I'm seeing that index is only when I'm pulling it out because of another value. So technically it would be order of 2n, but I don't think I would be doing the second operation that much, so I'm just like, overall it would be like order of n, and space complexity would also be order of n. I think this should work. I will have to see all the elements at least once anyways. I can't skip over that, so I am going to say this is actually the most optimal I can think of actually. Okay, so let's try to put the thoughts into code, and I'm assuming that you will be creating, like you'll have a deck in some way. In Python you can import from collections is what I know and how I have learned, so I'll say that, but it's just completely up to you. So this will contain nums and it will contain a value k. Okay, this is where we open. What I want to do is I want to first declare q is equals to, oops, in an object attention generally is, we'll initialize it here. Once we have done that, once we have done that, I is equals to j is equals to 0. We'll initialize both at the same time. Okay, now what I want to do, I want to store the index of the maximum element in my deck, right? That will be a easier check for me, but I will also do one more sneaky thing here. Let's move this a little down. I'll tell you what the sneaky thing is. Because I don't want like doing the same thing again and again, I will create one. Okay, let's remove this part. Okay, I'll create another helper function. Compare greater. What it does is it takes indices, it takes array, and it takes idx1, idx2. So compare greater will have the same logic as the comparator function in a sort does. Its only job is if ARR of idx1 is greater than ARR of idx2, I will return, what do I return? I return 1. Else if ARR of idx1 is less than ARR of idx2, I will return -1, otherwise I'll return 0, and that will be my helper function. Let's move this a bit up. This is something I have learned very recently, so I'm very fond of doing this, and we pick it up and put it a little up so that we have clarity. Okay, now that that is done, all I have to do is okay I is equals to j is equals to 0 हो गया. So okay, I will always be j minus 3. So I can actually just use one variable, so I can just remove this part and say I is equals to 0 से हम शुरू करेंगे. Why we will do that, I'll tell you later. Do I also need this part? I don't. I will use a for loop instead, right? Okay, what do I want to do? If I see a number that is greater than the tail of the deck, I want to pop everything from the tail until I get to a value where it is greater than the current number, and then I'll insert the current number. The other thing that I want to do is I want to the other thing I want to do is, if the first element has been removed from the sliding window, I want to also remove it from the deck. How do I do that? If I am at I, the index where my sliding window ends is I. If I'm standing at, let's say, 1 1 2 1 3 1, if I have a sliding window of this size of 4, so if I'm at 0 1 2 3 4 5, if I'm at 4, the element that I want to kick out of my sliding window is I minus k, because I want to kick this out, so it would be I minus k. So I have to just keep checking if I minus k is my front element. I just have to remove it, right? So that will take care of that. Okay, so what I have to do now is, okay, let's remove this so that I have space to create the pseudocode. What I'll have to do now is, for integer I is equals to 0, I is less than num's length, then I is plus plus. I will start the for loop here. Okay, now following the logic, while compare greater, what is it called? Compare greater of I and whatever is in the front. Which one do I want to be greater? I want I to be greater. The front would be dq minus 1, I mean the end. Now while that is the case, what I want to do, if my I is greater than this value, dq dot pop, it will just remove everything from the end there. Now once that is done, I have to now also dq dot push back, of I. Okay, now one interesting fact is, if this could make the whole queue empty, so I will do one more thing here. Instead of putting this directly here, I'll put one more thing for and dq empty is false. So while this is the case, while the dq is not empty and I still have elements, and then I compare that, I will continuously remove the element from bottom of the queue and will just pop. Once this ends, I'll dequeue pushback of I. I'll do a dequeue dot push back I. Okay, now I have added that. I need to do one more check of the part where I check if the front itself is I minus k. So what I'll have to do is, if dq of 0 is equals to I minus k, this is the case, I'll have to dq dot pop front, right? So if I pop front, I'm assuming that pop front is a function that will pop the front element out. So this will take care of that. For loop is still going on. Then what I would do is, for every I we actually can just print out the front. I think you can print out the front, or we can have a integer array answer all minus ones. And then I can do for I, actually sorry, answer of I is equals to dq of 0, the front part. Now there is the caveat that everybody might be screaming at me at this point about, what about these elements, right? The first three elements. If I get to here, this will be the front of the deck. When I get to this, the front of the deck will be 3, but if I put 1 as the answer here, that will not be the correct answer. I want 3 itself to be here, right? So I'll get to this point in the end, right? So for now, let's just keep it this way. Once this is done, we will close the for loop. Now for the last part, what if I run a for loop for I is equals to k? Do I need k or k minus 1? I'll need k minus 1 because that is the value that I want to place everywhere. Let's remove this. Thought process part was done here. Okay, so what we do here is, let's call it front max is equals to answer of k minus 1. That is where the first time it so happened that we had the first all max for that particular value, particular sliding window. What I want to do is, for int I is equals to 0, I is less than k, I plus plus, I will just do answer of I is equals to first max, and then we can return answer and close this function, and we would be done. So yeah, this is how you would approach this problem if you have never seen it, which I hope doesn't happen in an interview that you have not seen the problem when it comes. If you are still here, to consider liking the video and subscribing. However, if you want more to see more content, I would appreciate if you do that, because then I'll also get some appreciation out of it. And if you have any questions, any doubts, you can put it in the comments, and I'll see you in the next